Good afternoon and welcome to this latest MarkLogic webinar, Why You Need Data-Centric Architecture in 2024. Joining us today will be Daniel Roberts, Sales Engineer Manager from the MarkLogic side of the business here in Progress. If you've got any questions or if you've got any comments, then please feel free to use the questions throughout that. We'll have a Q&A between myself and Dan at the end, where we'll try and cover as many questions as we can during that time. But if we can't get to you, then we'll make sure to reach out and get you in touch with the right person. Short disclaimer, this presentation was put together by Daniel Roberts in their own personal capacity. It doesn't constitute any tax or legal advice. If you're watching this on demand, which you can do after this recording goes live, then you can pause this for the full disclaimer. So just before we go into the agenda, let's give you a quick background on this. You know, as organizations try to tie in their data and analytics strategy to specific decisions, you know, enabling new business initiatives, etc., they build applications in isolation and add new data streams to their data ecosystem, further deepening the proliferation of data stores across a large organization. A data-centric architecture provides a single source of information that is easily accessible across the entire organization. Because the data-centric approach treats data as a work stream, it helps organizations effectively manage the full supply of the data chains, transform a siloed business environment into a single architecture for democratized data sharing, and that taps into its enterprise knowledge. So with that, I will hand over for Dan for the full agenda that he's going to walk you through today. Dan, welcome on board.
Thanks, Philip. Thanks for the introduction. Yes, today we're going to be talking about a number of key topics around data-centric architecture. And the agenda we're going to look at, to start with, the key challenges which we see within our organizations and some of the key problems which many of our clients have. We're also then going to look at perhaps an ideological architecture. Of course, we all work in current systems which are well embedded and well utilized, so we never get to work on a greenfield site, but it's always good to have an aspirational architecture to move towards. So we're going to look at that, what would be ideal from that perspective. And specifically, then we're going to look at how we can leverage some of the common technologies and patterns which we see in our architectures, and how we need to leverage them specifically to make life easier and make a data-centric architecture a reality. Of course, we often talk about structured data when it comes to looking at architectures, but specifically, we're also going to look at how we can start to leverage unstructured data within this type of architecture. After talking about all of that, we're then going to start thinking about what we can actually do and what you can start doing in 2024 to try and alleviate some of the enterprise data challenges which we'll set out. And hopefully we'll provide a bit of a pragmatic approach, not the ideological one, but a pragmatic approach based on the type of technology you have today and what you might want to move to in the future. And of course, just to finish up, it would be remiss of me not to tie this all into leveraging large language models. Lots of our clients are utilizing generative AI or looking to use LLMs within their platform. So how can you tie these into your data-centric architecture? But before we go any further, I want to introduce a case study from one of our clients, which will work as a case in point for some of the items which we're talking about. Specifically, this client, a wealth management organization, started with a large quantity of systems within their department. This is a wealth management organization, a part of a much bigger business. And within that environment, they had a large quantity of fragmented systems, which made life extremely difficult for them. Namely, it made it difficult for them to provide the right data to their clients at the right time. They were trying to, of course, improve their business and ensure that their clients had the appropriate data they needed through the appropriate application channels, so they were up to date. But of course, when you have data fragmented in many systems that have grown organically over time, then it's pretty difficult to do that. Couple that, of course, with pressures of a financial organization, regulatory reporting. They need to ensure that the data is in the right place so they can do that simply and easily. For them at the time, it was very error prone and difficult for them to do. And they also wanted to streamline their business, which meant outsourcing some key functionality to third-party providers. Now, if your data is all over the place, how do you ensure that the data is with the right people at the right time? And that was a key aspect. And this is all in the context of projects which they tried to do before, which had failed, often the case when you have fragmented data. And of course, it was next to impossible for them to add additional functionality so that they could be competitive with other people in the organization. Essentially, over the years, this particular wealth management department had built new applications. And each time they'd built a new application, they, like most organizations, had coupled it with a new data store. Typically, when you buy packaged applications, they come with their own data store. And of course, every time you build your own applications, often we add in another data store. And so it's very easy to create applications that are isolated from one another, both in sharing data, of course, and of course, with their own schemas. All becomes a challenge. And what happens when you start adding just individual silos when you build a new application, you end up with what we call an application-centric architecture. And many organizations operate in this way today, and it's costly for them to do so for a number of reasons. In an application-centric architecture, we have product lifecycle management technologies, applications, we have e-commerce applications, we have CRM, you name it, all of the applications which you could imagine within your organization. And you couple that with wanting to build your own applications, and of course provide a platform for reporting and for observing the business as well. And it means that you end up with lots of point-to-point complexity. And each time you go to another point to grab some data, you end up having to map data and translate it from one schema into another. One of the key challenges in this space is the integration which is required to provide and create your application environment and your application landscape. In this environment, we end up dumping data into large data lakes, which then becomes ungovernable. We start mapping lots of data together, and we have an enormous library of microservices which we use to build applications, and it tends to be costly. And I think the key at the center of this problem is the fact that for the majority of organizations, they don't have a single enterprise vocabulary. They don't have a single way of describing their data across their organization. For example, if you're looking at a customer, we might represent a customer identifier in lots of different systems with completely different labels. For example, I might label them customer_ID, CID, ID, or customer identifier. And that makes life very difficult, especially when you consider you can multiply all of those attributes literally by thousands across lots of systems. It means that the ability for you to integrate data together and do it automatically and seamlessly in a manageable way is extremely difficult. And you can multiply this by the amount of applications you have, whether they're homegrown or packaged, as I alluded to earlier on. So if we can crack how we define all of our data and label it appropriately, that should ease the pain of doing data integration. And of course, improve the quality of the data associated with it. This Gartner quote here, they did some work and they identified that the majority of organizations pay millions of dollars a year because of poor data quality issues. And integration issues are additionally a problem, and it's been estimated that close to 60% of IT data costs also are attributed to data integration. So poor quality data and poor integration are the challenge of the day when it comes to these type of architectures. This, of course, is all coupled with the current environment where we see rising IT costs amongst increased inflation and increasing pricing pressures in all aspects of information technology, with increased prices from vendors, but also increased operating costs across the board. So what can we do to try and solve some of these problems and move towards an architecture that will perhaps help us to improve some of these key challenges? Well, as I indicated earlier on, this idea of an ideological architecture, something that we might want to move towards, seems sensible when trying to solve this problem. And we can relate this back to our case study later on. But I've kind of created this term information space, for want of a better word, to be able to take data from all of those different places and pull them into a centralized location. And during that process, harmonize our data and improve our data, and most importantly, relabel that data for our enterprise vocabulary. Now, the information space is a bit of a broad term and encompassing potentially many different technologies. Ideally, we would all love a single technology to put our data in, regardless of the use case that we require. But as of today, we don't really have that technology which can span the operational requirements of our applications all the way through to the observe the business analytical layer, which you would expect. So although I like in our ideological architecture the information space to be a single technology, I think we all know the reality that is not the case, and it's likely to be made up of multiple technologies. But the key here is, if we think back to fragmented data, if we fragment our data horizontally across lots of different systems with entities spread across, even though those entities might all represent customer data, for example, we find that it's very difficult to glue those back together. So the notion of an information space brings all that data into a central location in which we can build APIs, clean, well-defined APIs within our organization, which we can then expose and surface to applications which we have. And this is the kind of ideal architecture in my view. Can you imagine building applications which don't directly have their own data store, but they leverage an information space data store where you have all of the data associated with? The next amazing step beyond that, of course, would be to have packaged applications which leverage your own data store, but we're nowhere near that right now. Storing data in the information space makes life extremely easy. Everything's labeled as you'd imagine it, following your enterprise-wide ontology or vocabulary. All of that data within there can also be accessible from an analytical layer. And this is where we need to start thinking about technology specifically, because although there's no one technology to span operational and analytical right now to the level that many organizations require, the ability to pick the right technology in the right layer is important. And it's also important not to fragment data across those technologies. We want to be able to move data as a whole data set between, say, the information space and the analytical layer, or the information space and the interface and API layer, but we don't want to fragment them together. And so in that particular context, we'd want to start thinking about the types of technologies which we have and how they map cleanly onto what you're trying to achieve. For example, a data lake, as we mentioned earlier on, is of course an enormous capacity data store for structured, semi-structured or unstructured data. That's great. It's schemaless. We don't need to define anything. We can just throw data into it. But there are challenges with that, of course, because typically it's extremely low data quality, extremely poorly governed, but it might be extremely scalable and low cost. It's great if the data's right for analytics and data science. And so in the ideological architecture, I can see us having our single source of truth for data and still exporting data into, say, a data lake to do some really deep machine learning or analytics in that particular use case. But the key thing we need to do, the key rule from using any one of these different technologies, is not to fragment the data, the entities across those different types of technology. For example, you don't want a data lake with some of your entities in and another set of your entities in a highly structured data warehouse, which might be great for reporting, but you're not having a congruent view of data when you're starting to fragment data in that way. We need to use these technologies in the right tiers. So, for example, we can leverage a data hub because it's great for consolidating data, providing distribution and governance. It has the ability for a flexible schema, so we can pull data together and we can create high quality data governance type scenarios, apply lots of business rules to the data and ensure that it's everything we need for our operational workloads. And of course, we can define which technologies we use in between. Maybe the data lakehouse is a good technology for us to leverage to provide some flexibility. But I think we're going to see that we use these into all these technologies based purely on the characteristics. But remember, let's not fragment our data across those entities. Leverage whole data sets or subsets of those whole data sets within these technologies. So this kind of leads us on then to a data-centric approach for data. And if we layer that back onto our original architecture, we can start to think what this might look like. So again, we've got our packaged applications, our CRM system, our ERP system, CMS, or our product lifecycle management platform. But in this scenario, rather than having point-to-point between each of the different aspects of our architecture, we can start to bring that data back into a centralized platform, the information space, which has that well-defined vocabulary and those well-defined interfaces. And we can use that to build our applications seamlessly. So when we build new functionality to meet new business needs, we can leverage a single set of data, which we know is high quality. And we can also use that data as well to offload into other tiers for different initiatives where the characteristics of the technology meet the requirements. Perhaps that's some deep insight and deep machine learning which we could leverage. This, all in all, helps us to mitigate some of the challenges which we see in organizations, the continual proliferation of systems which we see, to mitigate against those 27 systems which we saw in the original case study. Now, this situation has persisted over decades, and some of my largest customers and clients that I work with, large enterprises, have many thousands of employees. One, which springs to mind, who has 40,000 employees roughly, said to me that they have approximately 30,000 databases. Probably logical databases, but still 30,000 data stores across their organization. To my mind, that's an unsustainable growth of systems, an unsustainable growth of data. It becomes unmanageable. So with a data-centric approach, we can look to start to reduce that. Of course, we're not going to this isn't going to happen overnight. This is going to take an extremely long period of time to get there. But we can start at least reducing some costs, reduce the amount of systems, improve quality and governance, of course, and increase the agility that we'd expect from our data and our systems. So what are the ideal requirements then for data for us to drive this data-centric architecture? Well, of course, the first instance is the notion of a common language for data. And what I mean by that is maybe a common model, but probably more of an ontology for describing the attributes and data which we have within our organization. Of course, that's going to be really useful in the first instance, but data needs to be described. We need to understand it. So we need to start thinking about also how we can enrich that data with metadata, describing various different aspects of it, about its discoverability, its point in its life cycle, maybe data lineage associated with it, or representing some knowledge associated with that data. So enriching with metadata is another way which is ideal for helping us to create that single data set, which is really what helps us build our applications in an agile way. This, of course, gives us the ability to create a single source of truth, or a data 360, if you like, from across our organization. And crucially, provide ourselves with a congruent view of data. Now, I've worked with organizations who have many relational databases and data stores across their organization. And when a particular business unit needs to do something associated with that data, when they need to do a report or figure something out based on a data set, and they take data streams and they pipe data from lots of different data stores into a new data store which they create. The challenge is then they end up with data which is out of sync. This data may be a day old, this data might be 3 weeks old, but they end up putting it together. So they don't have this congruent view, and it makes their ability to do reporting which can be trusted very difficult. So that congruent view of data is something which is crucial, which needs to be worked on, and especially important in these organizations today, that we can get that from trying to create a data 360, a single source of it. But then the final requirement here, which I always think makes sense, is to try and break this tight coupling that we typically see in enterprise IT between applications and data. I think it's easy to see that the tight coupling between applications and data kills data agility and massively increases integration costs. When everything's locked away and isolated and built independently, all of these labels are different. We have to do so much mapping, so much ETL, generally makes life extremely difficult. Hence the rise of data-centric architectures to try and solve some of these problems. So we've spoken a lot about structured data. What about all of the unstructured data within our organization? For example, the social media messages, the documents, the internal chat messaging between your colleagues or groups of people, the audio and video, the metadata which we just described, or perhaps even something like log files or streaming data, which could come from anywhere, from data that can come from our archives or data that could come from research documents, for example. How do we leverage that within our organizations and within our data-centric architectures? One of the challenges which we see, of course, is that 80% of the data which we have in our organizations is unstructured. However, if we couple that with the amount of data, the data which provides the real decisions, it's 90% of that data comes from structured data. So 20% is used for all of the decisions. But there's a lot of knowledge and facts and interesting things within unstructured documents that aren't being leveraged. How can we use that as an opportunity? And how can we build that into our platforms? However, clients are looking more at leveraging unstructured data and starting to put the technology in place to do that. And I think this is increasingly important for organizations, especially in the context of some of their analytic and AI journeys. We see lots of reports internally. We see lots of text in applications. How can we leverage that for analytics? How can we leverage that for our AI journey? And what are the strategies associated with that? One of the key things when it comes to unstructured content is how can we turn some raw text, for example, here, a patient report, into something which is structured. Structured data, we know how to query and access and get value from with structured query languages like SQL and Sparkle, for example. But all of that information in the raw text might have been written by one of our employees, but it remains locked away from the majority of applications and locked away certainly from our reporting capabilities. What we want to do is translate that into something like the table we have on our right, where we can see specific facts from that data. We can see about our patient, we can see dates, we can see, in this particular medical example, treatments and dosage. What we need to do is pull that data out and represent it in some way. And in fact, we've actually been doing this for some of our clients. One client that springs to mind, a reinsurance client, much of their business was operated based on documents and documentation. They might be reinsuring a oil tanker or a jumbo jet, but they still wrote down all the insurance legs associated with it in a document called an insurance slip. That's great for quickness and easily being able to read your contract, but it's extremely difficult to look at a whole stack of contracts and say, what is my exposure in the South China Sea, for example? They had this problem, and the only way they could solve it is by humans delving into the data and extracting it manually. So we worked with them and some of our technology to show how we could start extracting those facts out of those documents. This is an example application which we built on the screen here. This is obviously not using their data. This is just using Form 10K annual reports, which we store in MarkLogic database management system in our platform. But we use our Semaphore technology to, as you can see on the top right here, to pull out a few key entities within the data. So we've looked at this unstructured content and we've pulled out the jurisdiction of this company, the company name, the type of report it is, and also some facts and figures. In this particular example, the market capitalization as outlined in this document. And what we can do with that is we can take those facts and we can then put them into something structured. In this particular instance, we're storing them in a knowledge graph. And then we can use that knowledge graph to run some analytical functions across them. So here we're saying, can you give me a list of all the companies in a particular jurisdiction and order that based on their market capitalization? Something easy to do when you have the data in a structured format, but it's impossible to do when it's effectively a Google query. So what are the key benefits that we see then from our data-centric architecture? Well, of course, the first one, very much simplifying our architectures because we are decoupling applications from data, and we know that's going to give us increased agility. It gives us the ability to do a data 360, so pull data together from all of those different sources into that single information space. I guess that's a bit of a vague term, but I quite like it. Help us to mitigate the proliferation of our systems and, of course, reduce massively the integration costs which we typically have. And couple that, of course, with some of the increased benefits we get around accessibility of data. Remember, they're not isolated and locked away in lots of different data stores. When we're focusing on data, we're having data in a single place where we can unify governance, we can increase data security, we can do all kinds of other things, which we'll get to shortly. But what is the reality today? The reality today is that we will continue to get more data. Of course, new requirements come up, businesses move forward, new data sets are available, and everyone wants to use them. So we continually fight against more data needs and more data sources. And of course, that creates more complexity and more costs. So the challenge is, how do we look beyond a data-centric architecture which might exist within the context of a department or application and look to a more organizational wide strategy for managing data? Now, one of those strategies which you might be familiar with is the data fabric. The data fabric really kind of takes the data-centric architecture and kind of moves it forward and adds in some additional key concepts that are going to help us when it comes to building our data-centric approach. So, like the data-centric approach, the data fabric has lots of important things in it. Of course, we've got lots of data sources. We've got knowledge graph capabilities. We've got lots of metadata in there to describe our data. We've got a place for data delivery and data preparation. That would probably be our single information space, which we were talking about. And then layered on top of that, a set of capabilities for orchestration or for APIs and ultimately the top data consumers that consume those. But the great thing about a data fabric is that it introduces this concept of a data catalog. So within our single information source and our well-defined set of interfaces, the data catalog allows us to capture the meaning, the description, and lots of other interesting metadata which we would need to be able to consume and leverage that data across our organization. So we can think of all of those original data sources which we have across our organization. We're pulling them together into an operational data source of some description, which in this instance, as I say on the slide here, is made up of perhaps a data lake and a data hub. That is the contents of the information space that we talked about. And during that process, in that space, we are curating, harmonizing, improving that data and making it available. But additionally, in the data fabric, we're also adding a catalog of information and metadata about all of those data items in the operational data store. For example, we're providing information about the structure of the data, the canonical structure of the data, or the enterprise vocabulary, I guess, for another example, another way of describing it. We're talking about business glossaries and how terms relate to one another. And we're providing information, unstructured descriptions of the data which is in there. And we can also provide technical information about endpoints and how to access data as well. And so the data catalog can go really nicely and couple nicely with our data-centric approach to show a way somewhere where application users and developers in the organizations can browse, maybe subject matter experts can browse the data as well so that they can surface it and gain access to it, so they can surface it into their BI reporting tools, for example, or they could use it for protection, predictive analytics platforms. So the data catalog really augments that notion of a data-centric architecture and gives us the ability to easily access that data, which is one of the key challenges which we often see in the application-centric approach. Data is not available, it's locked away, it's not accessible. But with a catalog pointing the way, we can easily and in a more agile manner get hold of and access that data. And remember, the data-centric approach means that the data is high quality and is well governed and is securely accessible. So all of those things are a vast improvement over the application-centric approach. So the data fabric gives us a whole set of advantages to help us, leveraging capabilities of the data, identifying it for use cases, supporting both operational and analytical use cases. It gives us the ability to learn the behavior of our users and our communities so that we understand how to better provide that. And we can leverage that data across a whole different set of data management requirements and leverage it in different applications or use cases. So data fabric is a key aspect of providing distributed data across our organization. But I think that's just one key strategy which we also need to leverage and work on within our organizations. Another approach which the data fabric and data-centric architecture lend themselves to is the data mesh. And the data mesh really is, like any of these concepts, they're not a key technology, but the data mesh provides a framework to help you deliver some of these approaches. One of the challenges which we often see in organizations is the centralization of technology functions causing challenges across the organization, and they tend to hinder agility and provide bottlenecks for getting hold of the data. In a data mesh, we're going to leverage the data fabric and data-centric architecture approaches, but we're going to consolidate those and provide ownership of those in a decentralized manner in the lines of business, in the places which produce the data and understand the data as best. And this allows us to provide a self-service capability with the data fabric, data catalogs, with the centralized ownership to other departments across the organization. So you can imagine a scenario where a sales organization exposes a data catalog within its business unit that can be leveraged by the HR department, for example. They could utilize that so they can do bonus calculations at the end of the quarter. They know that the data that's provided by the sales organization is well governed and it's of high quality and can be relied on. Of course, you don't want a situation where all of these different departments are doing their own thing. So there needs to be some level of governance or standardization across the organization. And of course, like technology in general, applying to a set of rules, well-defined rules, helps smooth the oil of data across our organization. So for example, although the data is managed and owned by these lines of business, you could leverage key aspects of security and metadata and observability, perhaps data lakes with and data and machine learning capabilities, as a wider infrastructure. But the data ownership goes to who knows the data best. And this decentralization of ownership, I think, really provides some key capabilities to improve and increase the agility that fits very nicely with Data Fabric and also with the data-centric approach, which we've described. So the data mesh has a number of key capabilities and key benefits. The key ones to me are, of course, agility. We always want to improve how fast we can do things, improve faster time to insights. Remember, the data fabric and data-centric approach are providing quality data. And we get that by providing data ownership by the people who produce that data. And of course, this modular architecture at an organizational level means that we can also do interesting things like improve governance and reduce the bottlenecks of a centralized IT function. So what are the key things which we can do to try and realize some of these benefits within our organization? How do we, in the first instance, deliver our data-centric architecture? Now, many of our clients that we work with effectively are delivering data-centric architectures because they're focusing on their data. They're looking to consolidate their data in a centralized platform. And our multi-model database management system, our multi-model data platform, allows you to consolidate data from many different data sources. That coupled with some graph capabilities to show how we can store, enrich, and provide metadata, show relationships between entities, and understand, store metadata which we've generated from unstructured content using our semantic AI platform called Semaphore. All of these things help to unify data, provide data governance, improve data quality rules, and improve data security so that you can build the applications that you need within your organization. So in the first instance, what is a data hub and how does it help in this particular aspect? So a data hub, very much so, is a technology to integrate and ingest all kinds of different data into a centralized hub. And once it's in the hub, we want to be able to leverage the hub functionality to curate data, to harmonize it, to apply data business rules, data quality rules, to apply security controls to it, and effectively unify a set of disparate data sets into a centralized place. This is distinctly different from what we often see within our organizations. The typical enterprise flow where we have a run the business side and an observe the business side, and we spend a lot of time copying data from different places, from via ETL processes into data warehouses, into platforms to master data, into platforms to distribute data, and into data marts and data lakes, you name it. Multiple copies of data causing challenges within the organization. So the Data Hub works to mitigate all of these challenges and mitigate them by providing that single information source that we talked about, by just pulling data together, being able to provide capabilities to track lineage of the data, ability to enrich that data, and to build data flows that make agile data more easily integratable. Additionally, with our implementation of Data Hub, we also provide the storage capability for data. Some data hubs don't provide this. So we can do things like temporal data. We can go back to a particular point in time and say, what did I know and when did I know it? So all of these are key capabilities when it comes to building your data-centric architecture. Now, one of the other key capabilities which is required in our data-centric architecture is the notion of a knowledge graph. And we've touched on this a little bit. The knowledge graph is actually a very capable piece of technology which we can use in many places. as I alluded to in our discussion around unstructured content, we can extract facts and data and discover facts in documentation. We need to store them somewhere. And because those facts could be varied and wide, it makes total sense to store them in a knowledge graph. And in our case, we store them in an RDF semantic knowledge graph where we store the subject, the predicate, and the object of each data item. So it's immediately accessible and transferable within our organization. Of course, we can additionally store data from databases within there, and it may make sense to store some attributes from your structured and semi-structured data stores in a knowledge graph. And it's great for, of course, storing additional metadata or defining relationships between entities. And then finally, we did describe earlier on and talk about our enterprise vocabularies, and that actually those enterprise vocabularies could be defined as an ontology. And so that data can also be stored in a graph. So we can define the labels and names of things, and we can also define models, knowledge models for our data so that we know how to extract data from unstructured content. So together, our technology stack, MarkLogic server, the data hub, and our technology Semaphore help us to build applications that follow the data-centric architecture approach. The first instance, the data hub, we can leverage to pull data from any data source. So whether it's your ERP system, your some enterprise data which you have in a data lake, some data from a third party, mainframes or streams or any other kind of data. Remember, it's all different shapes and sizes and all labeled differently. Loading that into MarkLogic Data Hub, we can load it as is and then go through the process of curation and harmonization of data. Applying those unifying security, applying a data model, applying reference data and enriching it with metadata. And then through that process, then master that data and make it available for multiple different downstream systems, whether those are operational and transactional applications, or whether it's for analytical views, or whether it's to export into downstream predictive analytics technologies, or just to surface into a BI tool. So Data Hub helps us build that data-centric architecture. Now, the Data Hub typically is viewed as a technology for structured text, although they might be disparate schemas. Pulling those together in Data Hub is one of the key use cases, and of course the original driver for Data Hub. However, with Semaphore being the technology platform to understand our unstructured content, we can start integrating these two technologies together so we can ingest documents and document records that are unstructured into the hub, and we can leverage the Semaphore platform to classify them so we know what they're about, understand the aboutness of the whole document and parts of the document, allows us to extract facts and discover interesting facts within those, and then provide that capability and the metadata that process generates back into the hub so we can augment our data-centric architecture with data from unstructured sources. Semaphore works extremely tightly and well with MarkLogic. An example of Semaphore and MarkLogic together here would be on the right-hand side, an organization that has a large corpus of documents, whether that was in, say, something like SharePoint or within a file system. And we can leverage that file system, all of that document data into Semaphore, and we can process it via the classification server so we understand everything we need to know about that documentation, understand what it's about, enrich it with those tags and the metadata which we talked about, regardless of whether it's structured or unstructured. And once we've processed it, we can store all of that in MarkLogic. For those that know MarkLogic well, you'll know that it has a great search capability, whether that search capability is across structured, unstructured, or graph data within a single platform. And so we can augment that data with our graphs, with information from the knowledge model to do some really quite sophisticated queries in our platform. So on the user side of this architectural example, A user could be, of course, going to a search page or a BI portal where they want to search for information. But of course, we know that searching with keywords, for instance, like you would do against Google, doesn't always provide the right results for us. And we have clients that have struggled to get the right results with keyword searches in many technologies. But when you start enriching and classifying the data and applying a knowledge model against it and doing some classification, you can start to understand your unstructured content at a conceptual level and not at a keyword level. And with our semantic integration server, part of the Semaphore platform, we can integrate that with our search tools so that when you start searching for a particular keyword, we can integrate the knowledge model to say, well, actually, you're searching for this keyword, but this is the concept which you're actually searching for. And then we can leverage that to broaden or narrow the search terms and the search requirements. And coupled in with some type ahead search capabilities, you can start typing a keyword, but then it can suggest a concept for you. So there's some really powerful capabilities there, which allow us to build some great search applications that tie into our data-centric architecture. Remember, all of that data can exist within the single information space that can be used to drive your APIs as the single source of truth across your organization. Now, talk of all of this unstructured text leads us a little bit further down the line to asking the question, well, how does a generative AI platform or a large language model tie into this organizational architecture? Now, we know about some of the challenges with large language models, and we've talked about them on another webinar. So just to recap here, hallucinations. Of course, large language models like to generate things based on what it thinks the answer should be. So where data doesn't exist, it tends to make things up, and we've seen that with many of the technologies. Of course, large language models need to be generated, their neural networks need to be generated, and then they are static for a period of time until they are regenerated or through a machine learning algorithms at a later date. So we have data cutoff, so they're not always up to date. And of course, then there's the complete lack of explainability or reasoning that we see within large language models. So the key question is, how do we improve the quality of the responses of our large language models, considering these challenges? And also, from an unstructured text point of view and from a data-centric architecture point of view, how do we make sense of the output of these LLMs so we can generate identifiable and new knowledge which we can feed into our data-centric architecture? Now, the way that we can do this is with an architectural pattern called retrieval augmented generation, or the RAG architecture, as it is well known as. The RAG architecture effectively allows us to take all of the data within our organizational data stores, or of course within our data-centric architecture or data fabric, and pull relevant and important data into the request which we have sent to our generative AI platform. And this is where APIs surfaced from across our organization in a data-centric approach really start lending themselves to these new technologies. For example, you could build an application which takes a user query, and of course that could be in free text format, for example, as with ChatGPT or Google Gemini. And that query can be piped into an application that effectively intercepts that and searches your data-centric architecture for appropriate data, and then passes the appropriate data into the generative AI platform. Effectively, we're seeding the prompt of the Gen AI platform with relevant data, the additional data that it needs to enable them to give a more relevant response rather than creating a hallucination because it doesn't know. So this is one part of the story, but we can go a little bit of a step further than this by starting to introduce Semaphore as a technology that can understand the queries which come from the user. We can classify them and extract key facts out of those queries so that we can leverage them against a private data store in MarkLogic, for example. And so the flow would be, of course, we've ingested data and made it available in our data-centric architecture. Semaphore, of course, has marked up and captured and classified and enriched the data which we have within our data stores ahead of time. And then we can take user queries, we can then tag concepts in the user queries, and we can ensure that that tagged content conceptually pulls the right data from MarkLogic over and beyond what we would expect from a typical query search within the data set. And of course, then we can leverage that data back into generative AI with our augmented query to get a really great response, which we return to the end user. But of course, we can also intercept the response. And intercepting the response, we can also then understand the context of the answer and augment the response and show it how it is related to key organizational data which we have within our organization. So some really interesting capabilities when we start pulling in a data-centric approach as a way to get hold of our organizational data to then start feeding our Gen AI platforms and Gen AI initiatives with better data. So how do we tie all of this back to our original case study, which we had with the wealth management company right at the beginning? The work we did with them over a few years has effectively eliminated the 27 silos which they had and enabled them to effectively build a data-centric architecture. By consolidating data from these different systems and defining that single vocabulary for their data, they've been able to build applications quickly and easily to build their own internal applications for managing data, also do that with near real-time data. They've been able to define a portal for their external clients and provide client dashboards because all of the data is consolidated. And they've also been able to generate internal client reporting applications, as well as mitigate all of the challenges which they had around regulatory reporting. On top of that, they've also been able to add in payments capability into that platform. So a real great win for these guys. It's massively increased their agility within the organization, allowed them to build use cases in months, whereas before it took them years, and there were a number of project failures, as we mentioned before. So just to sum up then, with what we've done with this organization, I'd like to do that with a quote from the head of asset management technology. And I've doctored this a little bit because he said with MarkLogic, but I've changed it to with a data-centric approach, we were able to do in months what we failed to do in years with our previous approach. I think that sums it up. When you get your data right, your agility improves and your costs also drop. So just let's finish up with some key takeaways. Focusing on the data will increase your agility, and it will increase your agility because when you focus on that, you realize that your data is fragmented and that consolidating in a single place will help master that data. It will help you remove the duplicates, and it will allow your business to work off a common data set, maybe organizationally, maybe in a small way inter-department. It'll certainly help you with the accessibility of your data via APIs and allow you to provide wider organizational strategies like data fabric and data mesh. Of course, the key things you've got to remember to do is not to fragment your entities across different technologies. Let's try and consolidate them into a technology, but move those entities as a whole, or subset of as a whole, into those technologies where we can leverage the key characteristics of that technology. We might want to keep things in a data hub for some analytics and our operational workloads, but we might want to expose that data and export it into a predictive analytics platform for some really deep machine learning. The data-centric approach really helps make that data fabric and data mesh a reality. And then the final key takeaway is that the notion of binding data and applications tightly, as we see in many applications we build ourselves in organizations and in packaged applications, often kills the agility and makes it really difficult to break down the barriers between those silos. I hope that was.
Oh, I don't know what happened there. Dan, are you still there?
Yeah, I'm still here. I'm not sure what happened.
Perfect. Okay, do you want to switch on your camera and then we'll get to the questions?
There we are. I don't know where my background's gone. How come you got your background?
See, it's all go over here. Right, so we've got a number of questions that have come in from the audience, and so thank you very much for asking those. We'll try and get through to as many as we can. We'll start off with this first one. So, how would a canonical data model relate to a data-centric architecture?
Right, yes. So a canonical model is, of course, key to a data-centric architecture. That's what we're trying to achieve. We're trying to achieve a standard model or a standard data set with appropriate labeling, which we can hang off all our applications and requirements from. So yes, it's a central theme in the kind of notion of the information space. That's what one of the key aspects that we're trying to achieve.
Okay. And then someone said, how is the information space different from a warehouse or a data lake? I think.
Well, so the information space is kind of, the whole notion is it's just an abstraction of underlying complexity. And what we're trying to achieve with that single information space, of course, is a canonical model. So the information space could be implemented by any one of a number of technologies, a data warehouse, for example, a data lake, a data hub, like I talked about from ourselves here at MarkLogic, or a combination of those. We see the use case study which I gave with our client. They leverage a data hub and effectively a data lake for doing predictive analytics on some of the harmonized canonical model which they have created. So they all exist together. The information space is kind of an abstraction, I think, really, just to help us understand what we want.
Okay. And could you please expand on not to fragment data? There are multiple groups, subgroups within organizations that makes it impossible to function without separated owned databases.
Yes, absolutely, I agree. And it is impossible in many organizations, certainly large organizations, which I'm sure we all operate in. It can be very difficult to do that. A single database with a single canonical model to meet everyone's needs is very difficult. However, in the context of, say, the case study again, they are the wealth management part of that organization is a manageable size of organization, which allowed them to consolidate data and to define that canonical model, as you like, as a term, to bring that data into that central place, so they could get value from the notion of a single information space or a data hub or a consolidation of data or and a canonical model within that realm to help them. So yes, you're absolutely right. I mean, across different organizational departments, there's always going to be issues of ownership, but the notion of an information space, to whatever level you can expand it within your organization, can add some real value by consolidating systems and adding new functionalities to applications much simpler.
Yeah, and like I say, looking at your data as a holistic thing, so naming conventions and things like that go across the organization rather than siloed in the application. Yeah, no, that makes sense. And then what if organizations say they were using the MarkLogic Data Hub, but the underlying existing data was in, say, I don't know, a data fabric, but they wanted to change it to a data mesh? Can MarkLogic handle changes to the underlying sort of structure of data?
Yeah, so you need to think of this at different levels. You think of the data you've got in systems and the complexity associated with that. Can we consolidate, harmonize, make that more efficient by pulling it together into a single space, as it were? Then, of course, we want to make that data accessible. So can we provide things like a data fabric on top of that, i.e. APIs with catalogs, so we can search and discover and identify and find the data that we want, and make those available across our organization. So yes, I mean, you can start with the data-centric architecture. We can expose data as APIs. That's useful. Okay, can we make it more formal in a data fabric and adding data catalogs? Great. Yes, we can do that. Can we then organize those in a data mesh? Yes, of course you can. That's, you know, more of an organizational strategy for how you get hold of data and how you define the ownership of your domains of data or your information spaces, as it were, across the organization. So yes, they're all interrelated and interchangeable. I think the key concept, though, is fragmented data everywhere is difficult to deal with, and can we do something efficiently to try and consolidate it is, I guess, the key message. And a data-centric architecture is focusing on data is really a key way of doing that.
Yeah. And I guess the other question here that we've got is, you know, how can you implement a data catalog? And I think you touched on it a minute ago, which is that value piece. It's looking at the value that you want to get out of that data that you have within an organization.
Yes, I think so. I mean, for a data catalog to work, then of course you need to understand, what are the key data sets that you need that congruent view of, that you can apply data quality rules, governance to. It can be high quality set of data, complete, not fragmented everywhere, and so that you can identify those and expose those across the business. And then you need to kind of understand metadata and generate and store and identify the metadata associated with that, things like endpoints, accessibility, all of those kind of things. So providing some storage for metadata, so a metadata catalog and some description and managing the metadata associated with it.
Yeah, and then in that new sort of data-centric world where you've got that centralized view of that data, are you able to, like, for cost saving benefits, are you able to switch off like source systems once you've done that?
I think it depends entirely on your environment. And I think if you think back to some of the earlier slides where some of the source systems were things like packaged applications, there could be a Salesforce.com, or it could be a CMS system or an ERP system of some description. It's going to be, you can't switch those off. For the most part. So we do have customers that have gone through consolidation projects, and they tend to be of bespoke systems which they built themselves, and they managed to consolidate data from external systems, then switch off external systems, and that becomes their new source of truth for everything. Yeah. So I've seen that, but I would say that majority of the times there's a combination of packaged applications and bespoke applications, which are so tightly ingrained in the organization, it's very difficult to do.
Yeah,
I think the whole part of this presentation is kind of to try and, there's an ideological view that we'd love, but what's the actual reality? But can we take some of those snippets out of the ideological view, which would help us to streamline what we have got?
Yeah. And so lastly, and just because we're running over a bit, but why not just virtualize your source data systems to create a fabric or a data-centric architecture?
Well, I think you can do that to a certain extent, but there are some severe, the challenges around complexity. One of the notions behind consolidation and the information space is that you're moving data, and that's becoming your single source of truth, and you're operating on a single entity, making updates and changes to it, and everybody is reading from that same entity. So although there are many different ways to implement that data-centric architecture, I think things like just virtualizing directly from the current source systems means that you continue to have all of that complexity, as well as potential performance challenges associated with that. So yeah, data virtualization will work in some circumstances, but for example, on the case study which I gave, they consolidated data and removed an awful lot of systems out of their architecture, and to give them some great value.
Yeah. Okay. Well, Dan, that was a masterclass in all things in the information space, whether it be data meshes, fabrics, or hubs. So thank you very much for that. If we didn't get a chance to get to your questions, then please feel free. We will reach out to you, but if you want to reach out to us, please feel free to do so. I put a playlist. Dan mentioned about the Gen AI stuff, so we've got a playlist on YouTube of our latest events, including a roundtable that might be of interest to some of you. But thank you very much for coming today. I hope you enjoyed the content, and I hope to see you again soon.
Thanks all.
Cheers. Bye.